Okay, so today we're going to discuss a type of regression which is called logistic regression. So this is specifically binary logistic regression. Binary because you have two factors for your dependent variable. Okay, and then we're going to use the file, the data binary.csv. So I already shared that with you. So may I request you to kindly upload it so you can use the import data set. Okay, import data set, and then wherever you save your data. Okay, so it's not here. So I think I placed it here. Okay, so we're going to use the binary data set, binary.csv. Okay, so you only have here 4 variables. You can see here, binary. Okay, this is our data frame, admit, GRE, GPA, and rank. Okay, let's import this. Okay, so binary, there are 400 observations and 4 variables, admit, GRE, GPA, and rank. So do you have it, guys, now? Kindly,
Yes.
please. Okay, good.
Yes.
Okay, good. All right, so you have here admit. Okay, it only has 2 values, 0 and 1, which means that there were 400 applicants here to a certain college, certain university. And this was, 0 means that the applicant was not admitted. 1 means the applicant was admitted. So side by side with the variable GRE, okay, and GPA, and then rank. The rank refers to the type of school. A very good school has a rank of 1, a not just a good school 2, 3, and 4. 4 being the not so good school. Okay, so we'd like to make use of these variables in order to predict whether a student was admitted or not admitted. Admitted is 1, not admitted is 0. And this model can be used later on. For example, if a new student comes and has a GRE of this value and a GPA of this value, and the school where he came from, the rank is this value, then we can predict whether that student will be admitted or not based on this model. Okay, so here we're going to make use of logistic regression. And then next meeting, we're going to compare it with using another random forest model. Okay, we'll see that the reason here is that we want to compare the difference between using a regression model, a logistic regression model, and a machine learning model, and see which one gives us a better prediction. Okay, so when we look at when we run this, okay, the structure. Okay, so let's run the structure. Okay, wait, sorry. I haven't run this. Okay, it's taking some time again. Okay, kindly run this, guys. And you notice that the variable admit and rank, they are integers. Am I right, guys? They're integers. But we don't want them to be integers. We want the variable admit to be factor. Okay, because 0 or 1, 0 if the student was not accepted, 1 if the student was accepted. And then also the rank, we don't want it to be numbers, we don't want it to be integers, but rather we want them to be factor. 1 being a very good school, excellent school, 2 being a good school, but not that excellent, 3 being just a so-so school, and 4 being a not so good school. Okay, so what's happening to my, okay, I hope this doesn't bugs down. This does not bug down. I already imported the data, so Okay, so let me just escape this. Okay, so let me call my data so that we have the same name. Okay, binary. Okay, because I have here the binary data, so I'm going to rename it as my data. Okay, so now I have my data here. I should have my data here. Where is my data? Okay, where is that? Okay, it's still running. Taking some time. Okay, we're able, by the way, guys, to okay, what we should have done here was to copy this, guys. Control C, copy that, and then replace this one. Okay. Then replace it with my data. Okay. I should have done this. I forgot to do it. Okay, same with you guys. You should have copied this one and then pasted it here. And then we can now run this. I'll run it. And I hope I have now my data here. Is it already here?
Sir, is that the same with the binary file, sir?
Yes, yes. Yes,
Okay.
the my data is the binary. Okay, so it's still loading. I just copied when we imported the file, I copied the code here in the console window. I copied it here. Okay, and then retained the my data here. Come on, come on. Why is it taking so long? This should be a very easy code. How about you guys? Were you able to load my data?
Yes, po.
Yes, sir.
Yeah. Okay, that's a problem with my computer now. It's taking long to. Okay, I better close this. Okay. What happened there? It's not reading, it's not running. Okay, this one. It's just a simple code. It's just reading the file.
Just use my data from binary po.
Sorry.
Sir,
Yes.
use my data from binary.
Oh, yeah, we replaced that. We called it my data instead of binary. Yeah, I just copied this one. Okay, copied it and replaced the code here. And then we're calling it my data. Okay, but my data is, let me just close that. Don't save. Okay, let me open again that file. Okay. Okay, so very quickly. Oops. Where's the logistic? Has it opened? No, not yet. Okay. All right. Let me close this. So where is it? It has not opened yet. Let me quit, guys, the this is sometimes my problem with my computer. Sometimes it just hangs. Yes, let me quit. Yes. Oh no. It's here again. I think the idea to have a separate recording of this was a bad move for me. So it doesn't close and it's hanging, it's not running. Oh boy. Okay. Okay. Yes, I want to terminate it because it's not running, it's not moving, and yes, I've been telling you, yes, I want already to quit session. This is my problem with this one. So it's still open. So you don't want to close? And you're not processing? So what do you want, R? Okay. Could somebody volunteer to show their screen so that we'll just discuss the flow while with you presenting? Would like to volunteer to present his or her screen?
I can share my screen, sir.
Okay, thank you, love. Please I'll stop share.
Sir, pa-share po ng access.
Haven't. Oh, wait. Yes, nga pala, no? We already closed our session a while ago.
Yes, sir.
Okay.
Can you see my screen?
Yeah. Okay, so how can we increase this? All right. Okay, so we're looking at row number, guys, can you see the screen of the computer of Love? Can you see?
So very small.
Very small. Love, can you go to, can you increase the size? Go to, where's the tools there? The tools tab.
Which one, sir? Hold on.
Okay. Global options, global options there, and then appearance.
Appearance.
On the left side there, up there. Okay, then maybe make it 100%, please. Zoom, or 110%. Okay, let's see. Okay, is that better? Sister, can you see now?
Yes, better, sir.
Okay, so I'm looking at row, at the chunk, row 15 to 20, where we uploaded, where we imported our data, which is the binary data, and we gave it a name, my data. Okay, so if we can see the structure, your rank and your admit is integer, right? It's integer. Admit is integer and rank is integer. We don't want them to be integers. We want them to be factors. That's why in row 18 and 19, you have our object, my data, and then the variable admit. We made it as a factor, okay, and we still retain the name, no? Admit and rank. So kindly run 18 and 19, Love. Okay, good. And then kindly run 17, row 17. Let's see if the, okay. So you now notice that your admit and rank are now factors, right? So we have converted them into factors. Okay, so let's go down. Okay, let's just check. The X tabs, cross tabulation, will put admit in the Y-axis and rank in the X-axis and see how many of those admitted come from rank 1, 2, 3, 4, etc. So kindly run 25. Let's run row 25, please. Okay. So you should have this, guys. Notice that this is a cross tabulation of those who were admitted and not admitted, and their corresponding school rank from where they come from. So these are applicants to, I think, an MBA class, okay, MBA course in a university. So those who were not admitted are those in the first row. Okay, 28 were not admitted, coming from rank 1 school. 97 not admitted, coming from a rank 2 school, etc. Okay, so this is very easy to understand, this cross tabulation. So let's go down, okay, and notice that in row 29 up to row 33, we are again partitioning the data. Okay, so set that seed 1, 2, 3, 4, so that we have the same sample size. So our index, okay, sample, 2 samples. The number of rows is the number of rows of my data. Again, we use with replacement, and then we split our data into 80% and 20%. Okay, the first data set we call train, those that have an index equal to 1, and the second data we call it test, those that have an index of 2. So kindly run that, the whole code chunk there. Okay, so we now have, if you take a look, we now have our train. Love, can you go down, please? Sorry, in the environment window. Okay, you have now there below, the trained data set has 325 observations, and the test data set has 75 observations. So because we split the 400, our data set, our my data has 400 observations, so it was split into two. So approximately 80 and 20%. If you click train there, please, okay, it will show. So you notice it's you notice the index number 1, 2, 3, 4, and then 6, 7, 8, 9, 10, 11, 12, 13 on the left side, love. Okay, on the first column on the left side, you can see there the index 1, 2, 3, 4. The numbers there on the left column.
This
And
one,
then,
sir?
yeah, there's no number 5, right? 1, 2,
Yes, sir.
3, 4.
Yes.
No number 5, no number 14, which means that those samples went to the other data set, the trained data set. Okay, that's what that means. Okay, so let's go back. Let's go back to our code. Okay, so where are we now? Okay, we have just finished row 34, right? Okay, so we're going now to create a logistic regression. Okay, in R, if it's just multiple linear regression, use the LM function. Okay, but this is logistic regression, so we use GLM, generalized linear model. Again, if it's just a multiple linear regression where your dependent variable is a continuous variable, okay, we use the LM function. Okay, so here we use GLM, which means generalized linear model, and then we're regressing admit, and then there goes again your tilde there, admit, your dependent variable is admit, and you're regressing it on GRE, GPA, rank, okay, and then comma, data is equal to our trained data, and family, we have to include this family, is equal to binomial, which means that your dependent variable has 2 levels, 0 being not admitted and 1 being admitted. Okay, then you have summary. Okay, so let's run that, guys. Let's run the whole chunk, 38,
This one,
39.
sir.
Yeah, that one. All right, so we now have there, okay, that this is now the result of your regression. Okay, I'm sure you have met this in your in your Statistica before. So you have your regressors, your intercept, your GRE, GPA. Now take a look at rank. How many ranks are there? There are 4 ranks, right? Rank 1, rank 2, rank 3, rank 4. So if you will review your regression, guys, since there are 4 ranks, then we only introduce 4 minus 1 dummy variables. Okay, 4 minus 1 dummy variables, which means that when we do regression, if the variable is categorical or if it's a factor variable, okay, depending on the number of levels, then we will only introduce, the model will only introduce n minus 1 dummy variables. Okay, so the rank variable has 4 levels: rank 1, rank 2, rank 3, rank 4. Okay, so what will appear in your regression model is just 3 ranks, 3 dummy variables. Okay, and I'll discuss in a while how this is interpreted. Okay, so what does this mean? So your intercept is significant. GRE is not significant, right? You notice the asterisk there on the right side corner. So that means that GRE is not a good predictor of being admitted or not being admitted. And then GPA, you see the 2 asterisks there. Okay, the p-value is 0.002, which means that it's statistically significant. GPA is a good predictor of being admitted or not. And then you have the rank 2, rank 3, and rank 4. Okay, rank 2 is not significant, but rank 3 is significant, and rank 4 is significant also because they have 2 asterisks there. They're significant at the 0.01 significance level. Now, how do you interpret that, guys? For example, GPA 1.166. What does that mean? What does that mean, guys? It means that for every 1 unit of GPA, for every 1 unit increase in GPA, there's a, okay, there's a what? There's a 1.166, okay, log odds. So I'll explain next time what log odds mean, okay? Increase in being admitted. Okay, that's what the 1.166 there indicates. How about rank 3? Rank 2 is not significant, so we don't interpret that. Rank 3, negative 1.125. So the categorical variables, when it's used as independent variables, they are always used in relation to your benchmark. So what's your benchmark here? Your benchmark is rank 1 because it does not appear among your predictors. So that means that negative 1.125 means for rank 3 that rank 3 students has less chances, 1.1.25 less log odds chance of getting accepted compared to rank 1 students. Okay, of course, rank 4, negative 1.53 means that rank 4 students have 1.53 log odds chances of being accepted into the program compared to your rank 1 students. Okay, so love go down. Okay, and then so what happened here? Since GRE is not a significant predictor, we remove that from our model. Okay, so you notice in row 46, we now have my model. We again use the GLM function, and then we regress admit on GPA and rank. This time we remove GRE. Notice GRE was removed because it's not significant. So when we run this, can you run this, please?
This one, sir.
Yes. Okay, we run that. Okay, and notice now that GPA is it became more significant. Rank 2 became still not significant, and rank 3 became significant, still significant, and rank 4 is significant. So this is our final model. Okay, this is how we are going to model our admit variable. Okay, so love, could you go down? So let me just look at this equation and then we stop, guys. So what I'm going to do is, okay, do I have your permission just to extend by 5 to 10 minutes, guys? I'm sure you're hungry, but could we just anyway, there are just a few lines left. Is it okay?
Yes, sir.
Okay, thank you so much, guys. Thank you so much. Okay, but if you need to leave, it's okay, guys. It's okay to leave. Okay, so let me just explain that a model like this, a logistic regression, follows this formula. Y, which is our admit, right? Our Y, our dependent variable, is our admit variable, is equal to ln of P over 1 minus P. Okay, so it's different from the regular regression. Okay, because in binomial logistic regression, your independent variable Y is actually equal to the log of P over 1 minus P, where P is the probability of being accepted. So that's why this is called the log odds ratio, LOG, okay? Log, because there's a logarithm there. And the odds ratio is P over 1 minus P, ODDS, okay? So let me, Love, could you kindly write on the console LOGG, please? Okay, siguro sa ilalim na lang, under Y is equal to, so that, sige, log, LOG, then space, ODDS. ODDS, yes, that's the name, okay? It's the log odds ratio. Okay, so our model, guys, is Y is equal to log of the odds ratio is equal to beta null plus beta 1 times GPA plus beta 2 times your rank. Okay? So that's our model. Okay, so now let's compute now for the for Y for individual 1. Okay, so Love, could you kindly click where's our train data?
Sorry, sir.
Train data. Could you kindly click the spreadsheet and the train data below there? To the right, please. Okay, the spreadsheet. No, yeah, it's there. Okay, it's there. So we're going to look at sample. So data number 1. Data number 1, the actual is 0, which means actually it was not accepted. It was not admitted into the program. And the GRE is 380, the GPA is 3.61, and the rank is 3. Okay, so we're going to use that. Could you copy that, Love, that row there? Just the GPA and the rank. Let's see if that can be copied. Okay, the GPA, and just copy it under the console, please. Sa console na lang, to the right there. Okay, there, and then, okay, there. Okay, then just enter yung sa console. Enter mo na lang. Okay, sige. Now take a look at the equation, guys. So yung equation natin, y is equal to negative 4.727 plus 1.3735 times 3.61 plus negative 0.11645 times 1. Where did that come from? Go up, Love, ng konti, please. Okay, up again. Okay, so kailangan natin makita yung yung model natin, no? Up again. All right, up again. Sige. All right. Now take note, what's the parameter? What's the slope for integer? Doon ang galing yung negative 4.7270, no? Love, can you copy that, please? Yung yan, negative 4.7, kasama yung negative. Put it in the console sa ilalim. Yan, there. And then copy also yung GPA, yung 1.3735. Okay, copy it. And then just put it, sige, beside. Mag-space ka na lang, no? Space. And then also yung rank 2 hindi na kasi hindi siya significant. Yung rank 3, copy it, sige. Okay, and then yung rank 4. There. Okay, so take note, guys, that this is our model. So we were going to compute the value of your Y. Okay, the value of your Y based on these models, based on these values. So go down. I'll go down, Love, dun sa ano natin. Okay, so I'm just going to show you our model. Y is equal to negative 4.7270. Okay, that's our intercept, no? So kinapi natin yan, and then plus, while sa console lagyan mo ng plus, yung 4.727 plus, okay, plus, yan. After 4, yeah, there. Gagawa natin equation plus, okay. And yung 1.3735, that's the slope for your what? That's the slope for ano, guys? For your GPA, di ba? Love, pakita mo ulit yung 1.3735 up, di ba? 1.3735, that's the slope for GPA, right? So that should be 1.3735 times GPA, okay? And then why are we including it? Because it's significant. Take a look at the 3 stars, which means GPA is a significant predictor of admit. Okay, so we have to multiply 1.3735 by GPA. But what's the GPA of observation number 1? Balik nga ulit, Love, sa kay train data. Kindly go back to train data. Okay, there. What's the GPA of observation number 1? Diba 3.361? Diba? Right, guys? So we're going to multiply that 1.3735 by 3.61. Sige, i-times natin yan. Times yung 3.61. There. Okay, i-copy mo na lang kaya para ano, baka kasi may decimal yan. There, okay? So we copied the value of GPA and multiplied it by 1.3735. Okay, and then, okay, next is what's 1.1645? Before that, love, what's the rank of observation number 1? What's the rank of that student? From what school did he come from? Rank 1, rank 2, rank 3, rank 4? Diba rank 3, diba? Andun sa last column, rank 3. Okay, so let's go back to our model. Okay. Okay, it's okay. Sorry guys, anyway, you can review this video. Okay, and it's really so difficult to discuss while I'm not in control of the okay, take note of that, guys. Negative 1.61645. That refers to what? Rank what? Rank 3, right?
Yes, sir.
Now, is this student rank 1, rank 3, or rank 4?
3.
Rank what? Rank 3 or rank 4? This student, this first observation that we're looking at. I'll again go back to our trained data. Because we're testing, we're predicting, we're computing for the value of Y for our trained data. Okay, where's our trained data? Okay, maybe it's best. Okay, there it's. Now, what's the rank of observation number 1?
3.
3, yes, 3. So what we're doing now is we're predicting the value of Y for student number 1. So it's 3. Okay, therefore, love again, go back to our model. Okay, so go back to our equation. Okay, so negative 1.1645 pertains to rank number 3, right? Correct? Right? That negative 1.1645, that's the slope for what? For which rank?
Rank 3, sir.
Rank 3. So you have to, we multiply that by 1 because we will include that. Okay, we will include that in our model. Okay, times 1. Why are we multiplying it by 1? Because this student is rank 3. Therefore, that factor has to come in, has to be included. And then the last one, negative 1.5642, that's for what student?
4, sir.
4, that's for rank 4 student, but our student now is rank 3. So you multiply that by 0. Okay, because that should not be included because that's for rank 4. Okay, kindly compute for that. Enter. Love, enter. Okay. So it's negative 9,33165. So let's go back to our equation. Okay, below. Okay. Now that negative 9,33165 is your Y. Okay, take a note, take a look at that. Maybe, love, you can copy the negative 1.5642 in the console times 0. You can copy it to the model in row 63. There, that one, so that it will be complete. Copy it there, okay? So that you understand what's happening there. Okay, so the result is 933.165, right? That's your Y, okay? That's your Y, but that one is your log odds ratio. Okay, that's your log odds ratio. And what we are interested in is the P. Okay, we're interested in in the P. So how do I now compute for the P given your Y? Okay, so it's very easy to show that your P is equal to e to the Y over 1 plus e to the Y. So based on the equation Y is equal to the log odds ratio, we can solve for P, and that and the P is equal to e to the Y divided by 1 plus e to the Y. Okay, so you'll now notice, guys, that in row 67, I already computed for the P. The P is negative e, that's exponential, and your Y is negative 933.165, and then divide it by 1 plus exponential negative 9.33165. Okay, so I'm converting the y, which is negative 0.933165, into p. Okay, so when love, can you copy that line 67, that equation only, don't include p. I'm sorry, that just the exp. Don't include the e to the y. Okay, just that. Copy it in console and then run it. Enter. Okay, 2822. Okay, so what's this, guys? What's this? 0.2822 is the probability that student number 1 will be accepted. So since it's less than 50%, so the model is telling us that our prediction is that student number 1 will not be accepted. Okay, is that clear, guys?
Yes, sir.
Clear ba? Okay, so so what's the prediction true? What's the prediction okay? What was the actual value, guys? Was student number 1 accepted or not accepted? Go to train. Okay, take a look, guys. Admit, what's the value?
1, sir.
Admit.
Sorry for 1, 0.
0, yes. So the actual, the reality is student number 1 was not accepted. And our model predicted that the probability of the student being accepted is 0.2822, which means not accepted. So our prediction was correct as far as student number 1 is concerned. Okay, so in a nutshell, guys, that's how this model computes for whether the student is accepted or not. If the p-value is 0.5 or more, then the prediction is that it will be accepted. If it's not, then if it's less than 0.5, then it will be rejected. So let's go just a few more minutes, guys. Let's go to the logistic regression. Could you kindly go up, please? Okay. So sorry, go down, please. So let's run number row 53. Okay. And then row 54. Okay, take a look at that, guys. So these are the first 7 values of the prediction of our model. Take note for number 1, it's 0.28822, right? 2822, and it's the same, except for some, of course, some differences because of the of rounding off, right? Our prediction was 282283. The actual computation was 2822956. So the first 4 decimal places are correct, right? So these are the predictions. So what we did a while ago was to illustrate how these predictions are done. Okay, so as a practice, you can now work on student number 2. Okay, follow the format and try to see if you'll generate the p-value equal to 2.9928 something. Okay, so we can compute for all of this, guys, the probability. Okay, using the log odds ratio, and then converting the log odds ratio into a p-value. Okay, which is p is equal to e to the y over 1 plus e to the y. Okay, so lastly, love, could you go down, please?
Sir, sorry, quick question.
Yes, sure.
So based on our prediction, for student number 2, we have 0.299, and from train, so meaning the student should not be admitted, right?
Yes. You go to train. Now, what happened was the student was admitted, right?
Yes, sir.
So that means wrong yung prediction natin.
I see.
Okay, it was okay. Okay, why don't we just one, guys? Just one. Let's try to compute student number 4. Let's try to see. Go to train. Okay, let's take a look at student number 4. you have the GPA of 319 and rank 4. Could you kindly copy that? Okay. All right. Go to console, love, and then copy that negative 4.7270. Okay. The one above. Okay. No. Copy that. Can you negative 4.72 plus 1 point, that one. Okay. Copy that. All of that. All of that. Can you copy all of that? Okay. Copy it below. Okay, and then let's replace 1.3735 times, it should be times 3.19. Please replace 3.61 by 3.19 because that's the GPA of, copy mo na lang, love, kasi baka may mga decimal places yan. Because that's the GPA of student number 4, right? And then
Yes.
negative 1 plus 645 times, what should it be? This should be times 0, right? Times 0 because this student is student number 4, right? What's the rank of this student, right? His rank is 4, right?
Yes, sir.
Take a look at the rank column 3314. Then let's replace negative 1.5642 times 1. Okay, so that should be times 1 because 15642 pertains to the rank of the student. Okay, so enter please. So that's the y value, guys. It's negative 1.90. And then copy the e exponential, love, please. Go up. Okay, that exponential. Copy that, Control C, and then go below. Okay, and then replace the number by negative 1.99.
This one, sir.
Yeah, that one. So that's your y, and we're going to replace e to the y, and also the one, the next one, there. Okay, run that. Okay, so what's the probability? 0.129. Okay, could you kindly take a look at our logistic model? Okay, what was the probability of number 4? There, 0.129, right?
Yes, sir.
Correct, and this one is 0.129. Okay, so we were able to determine how this is determined. Of course, because this is a software, it's able to compute everything at the same time. If we're going to do that manually, it will take us a very long time. Okay, so let's go down. Let's just finish this. Okay, so okay, so we can now compute for the misclassification. So take a look at row 80, okay, row 79. We're creating this object, predict 1, and then take a look, if else, okay, if else, if P1 is 0.5, then give it a value of 1, otherwise give it a value of 0. And then the confusion matrix, we know this table. Okay, so let's run this, run the chunk 78 to 82, okay. All right, here. So this is the result of our model. 208 were predicted as 0, correct. 29 predicted as 1. The actual is correct. And then so 15 and 73 are wrong. Okay. And then let's get the percentage correct and percentage wrong. Okay, 86 to 90. Run that chunk, please. Okay. So 72%, guys, 73% were predicted correctly, and then 27% predicted wrongly. Okay, and then we go to this one, the next one, the last one will be testing our doing the model for our test data, because we did it first for our trained data. Okay, so kindly run the whole 96 to 100, love. Okay, so go down, please. Okay, we didn't include the sum, no? The correct. So the correct one is 71%. Okay, 71%, and the wrong is 29%. What was the one above, love? for our trained data? Go up. No. The model. How many percent was correct for our trained data? Okay, 73%, 27. Okay, so for our test data, 29% was wrong as compared to 27% for our test data. Okay, go down, please. Okay, so just run that 105. I'll just explain that next time. Okay, so this just tests our model if it's okay, the goodness of fit, and it tells us that our P1 model, our prediction, our model for P1 is okay. So this means that the probability that the model is not good is very, very small. Okay, so I'll just explain that in greater detail next time. Okay, so guys, are there any questions? So let me just quickly summarize. In one sitting, we were able to model a logistic regression model. A logistic regression, a binary logistic regression model has for its dependent variable a binary data, which means yes or no lang, 0 or 1. So in our problem, we were trying to predict if a student will be accepted or not accepted. Okay, so we used logistic regression using the GLM function, and we were able to come up with our model, which was 73% prediction correct and 27% prediction wrong for our testing data. For our training data, 71% correct and 29% wrong. Okay, so that model is quite good. Okay, 73%, 27%. Okay, especially that the sample size is not that big, only 400. Maybe if this was bigger, maybe we could have a more accurate result. Okay, so your exercise, guys, is to try to do let's say decision tree first, guys. Try to do decision tree and try to see how your decision tree model compares with this logistic regression. Okay, so you have this logistic regression where you're able to predict your admit variable, and then try to do it with your decision tree and see if you'll have a better accuracy if you're using the R part, for example. Since you know already how to do the R part, then you'll be able to predict also, come up with a decision tree using R part, predicting your admit variable. Okay, so very good. That ends our okay. Thank you, love. So let me just pause our recording for today. Okay. So where's my pause here? I can't pause it anymore. Okay, so guys, thank you so much. We had to do some overtime. I hope you don't mind. I hope you learned something today. Thank you so much. Are there any questions before we call it a night?
None so far, sir.
Okay, thank you so much, guys. Thank you, love. Thank you,
Thank
sister.
you,
Thank
sir.
you, Rob. Thank you, Ronnie. Thank you. Please stay safe.
Thank
See you.
you.
Thank you. Please feel free if you have. Feel free to ask me, to PM me if you have questions. Okay.
Yes,
Okay,
You know
yeah,
my.
sure.
You know my messenger. Just chat. Okay, and then we'll try to
Yeah.
set a free time so that we can discuss. Okay. Keep safe, everyone.
Thank you,
Yes.
sir.
Yes,
God bless
sir.
you guys.
Thank you,
God
sir.
bless. Okay. Thank you.